Hey, this is Randy. Today we'll learn how to simplify roots of negative numbers. In order to do this, we'll use something called the imaginary unit, which becomes especially useful in advanced calculus and even in the study of electricity. Let's do this. So we need to express the following radical. Here's the radical in terms of I and in simplified form. Okay, before we solve this, let's talk about the concept of the principal square root. So in order to understand this, let's use the example of the square root of positive 16. What is the square root of 16? Well, 4, right? Because 4 times 4 is 16. But what else? Let's write 4 here. What else is the square root of 16? Negative 4, right? Because negative 4 times negative 4 is also positive 16. So the square root of 16 is actually plus or minus 4. Plus or minus 4. Now, what do we call it when we're talking about only the positive version of the square root? We say that that is the principal square root. So when you hear the phrase principal square root, just think positive square root. So now that we've talked about the concept of the principal square root, let's think about what is the square root of negative 25. In other words, what times itself is negative 25? Could we say negative 5 times negative 5? No, because that's positive. So let's cross this out. We know that negative 5 times negative 5 is not negative 25. It's positive 25. So how could we find the square root of negative 25? Well, that's where the concept of the imaginary number comes in. Sometimes you might hear this referred to as the number I or the imaginary unit. So first, let's talk about how do we define this imaginary unit I. To define it, we say that I squared is equal to negative 1. Okay, so now think about, what if I take the square root of both sides? So we say square root of the left and square root of the right. What do we get now? Well, on the left, the square root of I squared will give us a principal square root of just I, right? It's like the square root and the squared cancel. And on the right, we just have the square root of negative 1. So both of these are correct definitions of the imaginary unit, assuming that we're talking about the principal square root here. The principal square root of I squared is I, and the principal square root of negative 1, okay? And in future videos, we'll go into a lot more detail about how to deal with this imaginary unit. But for now, let's talk about what can we do with this expression, plus or minus the square root of negative 25. Well, we could describe negative 25, as negative 1 times 25. So let's do that. Now we can take this radical and separate it into two radicals. If we had two negatives inside here, we would not be able to separate it into two radicals, but because we have only one negative, we can do that. You can also separate something like this into two radicals if you have only positives, okay? So let's separate that, and then we'll go from there. And I'll also move this up here real quick. Okay, there we go. Perfect. Now in this topic, when we see a square root, we need to assume that we're talking about the principal square root in order to not have to say principal square root every time. So when you see this, just assume that it's principal, that is the positive square root. So how could we simplify this even more? Well, we just talked about the fact that the square root of negative 1 is I, right? That is the principal square root of negative 1, even though we're not going to say principal every time. We know that we're talking about the principal. So let's replace the square root of negative 1 with I and the square root of 25 with 5. Okay, perfect. So now that we have no more square root, we have plus or minus I times 5. Now when we have no square root, it's most common to write the I after the 5. So let's change that order there. And you'll see that I have these I's written, a little bit squiggly just to be able to distinguish them more easily. But if you want to write a normal I, that is totally okay. So now we have plus or minus 5I is how we express plus or minus the square root of negative 25. So this is like saying plus or minus 5 times the square root of negative 1. So when we see a square root of a negative number, like in this example, the first step is going to be to pull out the I. So then we can just find the square root of the positive version. So let's do another example now, a little bit more complicated this time. same instructions. So using the same logic of the first problem, what we did here is just take this -1, right? It's like -1 times 242 inside the square root, and we pulled that out and wrote an I on the outside, which represents the square root of -1. Okay, now how do we simplify this part of the expression? Well, let's do a prime factorization. So first of all, we can divide 242 by 2, so we'll get 121 times 2. Okay, perfect. Now we have 121 times 2 inside the radical. So what else can we do? We could say 121 is the same as saying 11 times 11. And there you go. Now we have a prime factorization of 242, which is 11 times 11 times 2, because all of those numbers, 11, 11, and 2, are prime. So sometimes it's useful to do a prime factorization because now we see that 11 times 11 is 121, which means that 121 is a perfect square. And when we're simplifying radicals like this, we want to pull out all the perfect squares that we can, okay? So if you're able to recognize the perfect square of 121 immediately, then you don't need to write the entire prime factorization like we did here, because you can just immediately say, okay, 121 inside the radical is what outside the radical? Well, that would be 11, right? Because 11 times 11 is 121, right? So this part of the expression right here, the square root of 121, we just rewrote as 11 outside of the square root. Okay, now what? So let's ask the question, can we pull anything else out of the square root? That is, are there any perfect squares inside the square root? There are not, right? Square root of 2 is as simplified as we can get. So how do we write the order of the answer? Well, typically, we'll put the number 11 before I. So you can say plus or minus 11i root 2, or you can put the I afterwards. I like to put the I before the radical so that we know that the I is not inside the radical. And there you go. Plus or minus 11i root 2, or plus or minus 11 root 2i, remembering that the I is not inside the radical, are perfectly good final answers. So let's do one more example here quickly. What do we do first? Well, let's pull out the I, because we know that I is the square root of -1. That way we'll have a positive number inside the radical, which is going to be 80. Okay, good. Now we want to pull everything out of the radical that we can. That is, any perfect squares. Let's pull those out of the radical. And if it helps you, you can do a prime factorization of 80. So you'll see that 16 times 5 is 80, and then you can pull out the 16. But I'm going to do a prime factorization right here so that we can see how to do that. So let's see here. 40 times 2 is 80. And we know that 20 times 2 is 40, so we could say 20 times 2 times 2. Okay, good. And we know that 10 times 2 is 20, so we could say 10 times 2 times 2 times 2. And once again, we could say that 5 times 2 is 10. So that would give us 5 times 2 times 2 times 2 times 2. That's 4 2s. Okay, so now where are the perfect squares? Well, we have, let's see here, 2 times 2 is 4, and 2 times 2 is 4. So we have 4 as a perfect square 2 times. And we also really don't want to forget this I right there. So we're going to have inside the square root 5 times 4 times 4. So now if we pull this 4 out, the square root of 4 is 2 on the outside, and it's going to be another 2 on the outside. So it's going to be I times 2 times 2 times the square root of 5. All right, good. Just to be super clear, this square root of 4 became a 2 when we took it out of the square root. And this 4 became a 2 when we took it out of the square root. So now 2 times 2 right here will give us 4. So we're going to have I times 4 times the square root of 5. And this can be rewritten as plus or minus 4i root 5. So you could have immediately recognized that 80 can be factored into 16 times 5, right? And then from there, you just pull out the 16. Then that just becomes a 4 outside the square root. And then you can see that this plus or minus 4i root 5 is exactly what we got the first time we did it. And with that, we are finished with the video on simplify roots of negative numbers. See you next time. Hey.